How's it going? I'm going to show you a quick demonstration of this ultrasonic sensor project that comes from this kit, a Arduino Uno R3 kit. So if you follow the diagrams, this should be lesson 10 or lesson 9, and the wiring diagram looks just like this. So we have ground on the black wire connecting to the ground right there on the module. 5-volt power again going to VCC, and then D12 and pulse wave modulation on 11. So D12, the brown wire, is connected to trigger, and then the white wire, which is connected to D11, the pulse wave modulation, is connected to the echo. Okay, so one of these transmits and one of these receives a burst of 8 pulses of 40 kilohertz. So just like a bat, it transmits and then receives, and then based off the calculation between the time of transmission and reception, you can figure out the distance. And so there's a formula for that right here in the manual. I won't go over it, but it's fairly simple. And there's just a diagram of how that works. Okay, so the trigger input to module, it gets a signal, and that signal tells it to make a sonic burst from the module. So there's your 8-cycle sonic burst, 40 kilohertz. 40 kilohertz is above the range of human hearing, which is 20 kilohertz. So that's why it's an ultrasonic sensor. So you cannot hear this sound. And then the echo pulse output to user timing circuits. So we have a way to receive the input back into the module, and then it is calculated. So there's your wiring diagram. And there's your image. Now we can open the monitor. And let's just make sure this is running. And upload. And it's not working. So let's see what the problem is. Compiled, no errors. And upload. Aha. I left it plugged in running, so I don't know. Maybe I caused it an error. Let's give it another shot. There's no error on the compile. It was on the upload. And it works this time. So now we'll look at the serial monitor. And as you can see, it's already reading. So we got 15 centimeters, 13, 19, 36. And if I point it up at the ceiling, I get 141 centimeters. If I point it at the wall across from me, oh, there we go, 1,182 centimeters. Now, let's see how accurate this really is. It says 2 centimeters. There we go. So now I'm not even touching the desk. I'm about 1 centimeter. There we go. So when I'm about 1 centimeter away, it gives me what looks like the maximum distance, which is 1,182 centimeters. So this module does have a maximum distance that it works at, and I'm sure that it has a range where it doesn't look so accurate. So it's going between 3 and 5 centimeters right now. It's only about 1 centimeter off the ground. So in reality, it looks like it's not too accurate when it's right up against the surface. See right there saying 6, now it's saying 2. So it almost gets the right reading, but at these distances, it's pretty close. Now the way I got this to work was I needed a library. So if you look, there is a zip file included with the kit. And if you don't know anything about C and C programming, this is CPP actually. So there's a header file and an implementation file. If you get errors in the Arduino IDE saying you can't find SR04 and you're having trouble installing the libraries, what you want to do is move these two files into the same directory where you're keeping the Arduino project, the sketch. And then the include statement up here will include that header and the implementation file. So there you have it, a simple project.